R-CADT is pleased to invite you to participate in the course. Industrial Asset Network Maintenance and PHM, Prognostics and Health Management. Applications of Artificial Intelligence and Mathematical Programming in Industrial Maintenance. Objective: Teach I, the theory, and 2, use cases of advanced, predictive and prescriptive analytical methodologies to optimize the behavior of industrial assets and their components, considering that industrial plants and equipment are the integration of multiple components. The course focuses on the applications of artificial intelligence, machine learning, and optimization applied to industry in general, with emphasis on fundamental industrial sectors. Initially, the fundamental mathematical concepts to carry out the PHM, Prognostic Health Management, process will be reviewed, and then the integrated optimization of industrial asset networks will be studied. The course is based on realistic use cases, in the following sectors: electrical, electric power generation, solar, wind, gas wind turbines, hydroelectric plants, interconnected systems, energy storage, and transmission and distribution, substations, transformers. Electrical circuits, oil and gas, pipelines, production fields. Mining, vehicles for the transport of minerals. Industrial, production units. Transport, vehicle fleets, and boats. PHM, Prognostic and Health Management. PHM, or Prognostics and Health Management, is an engineering approach that uses sensor data to monitor the condition of a system, predict its future life, and optimize maintenance. It integrates technologies to detect anomalies, diagnose the root cause of faults, and estimate the remaining useful life of components. Rule. The goal is to enable condition-based maintenance, CBM, or predictive maintenance, PM, to improve safety, reliability, and efficiency while minimizing costs and downtime. It is a comprehensive approach that uses insights from prognostics and diagnostics to manage system health and reliability through informed maintenance decisions. The key components of PHM are: prognostics, predicts the future state of a system and estimates its remaining useful life, RUL. Diagnostics, identifies the root cause of a fault or anomaly. And health management, a comprehensive approach that uses forecasting and diagnostic insights to manage system health and reliability through informed and optimal maintenance decisions. The course introduces the integration of predictive analytics and prescriptive analytics to produce optimal maintenance plans. Decision-making artificial intelligence is a new term, coined by High to refer to optimization algorithms aimed at decision-making. It could be said that its birth coincides with the launch of the ENIAC computer, in 1947, which gives voice to digital iterative algorithms such as the simplex method, created by Danzig. It is very little known, and there are very few companies specialized in this area of knowledge. High is one of them. High has accumulated 50 years of intellectual property in this field. Artificial intelligence can be defined as the union of two artificial intelligences, predictive or traditional, and the prescriptive, aimed at supporting decision-making. Objective and structure. Aimed at professionals, engineers, mathematicians, physicists, consultants, economists, data scientists, software developers, etc., who require and or wish to know mathematical modeling, advanced analytics algorithms, related, among others, to the implications of Industry 4.0 and its relationship with the process of evaluating the technical economic impact of the decisions that are made. This continuing education program strengthens the analytical skills and professional criteria of the participants, so that they can exercise, share and or supervise, with propriety, the professional functions in accordance with the state-of-the-art of the methodologies and technologies that support the digital transformation of the companies. Mathematical methodologies. Mathematical methodologies correspond to the scientific foundations for implementing mathematical optimization models. Specific objectives: training in fundamental methodologies to support modern mathematical modeling. To train so that the mathematical modeling of industrial and business processes is a generator of real socioeconomic wealth frequently used in our society. Understand that optimizing the use of resources is the scientific basis of sustainable development. Learn about systems and industrial market modeling. Learn the fundamentals of modeling real problems based on the integration between mathematical models and data models. Information technologies. Computer technologies correspond to the computer tools available, freely or commercially, to design and implement solutions to problems in social or industrial organizations. Specific objectives. Learn how to implement solutions applied in the real world by making use of the modern computer technologies available for the algebraic modeling of industrial and business systems. Present and manage live tools used by large companies to solve their optimization problems. Understand the state-of-the-art of optimization and its relationship to smart computing. Know the available technologies, as the principle of basic knowledge to be able to solve, in reasonable times, problems with millions of variables. Know the fundamentals that must be had for the assembly of models using the most effective technologies. Optimizing maintenance in industrial facilities is a function in which operational efficiency is key to the viability of companies. From the initial development of a factory and factory network, engineers must include operational plans for the maintenance of industrial assets, and these must be constantly updated as new information becomes available about the operation of the equipment. The use of operations research, or, involves applying mathematical modeling, optimization, and simulation to complex problems for team planning and scheduling to improve efficiency, reduce costs, and maximize profitability. The digitalization of factories, together with IoT, has given rise to PHM, Prognostics and Health Management, based on online artificial intelligence. Theme Plan. Value Chain Optimization or Enterprise-Wide Optimization. Operations research uses the scientific method to address organizational problems, focusing on providing management with a mathematical basis for decision-making. It is not a science, but more the application of science, logic, mathematics, statistics, and various theories to managerial and administrative problems. It focuses on organized systems, using interdisciplinary teams of scientists and engineers. Operational research began in 1937 in Britain and developed in countries such as Australia, Canada, France, and the United States. A company's value chain is made up of two chains, strongly interrelated. Demand chain determines all the processes that are carried out to attract customers in the markets, and supply chain determines all the processes that are carried out to produce the products that customers want to consume. The diagram presents the chain of the company's production chains that together make up the value chain. One of the greatest evolutions in the modeling of companies occurs in the interpretation of their value chain. The diagram presents the evolution of different administrative practices in companies, which are linked to technological solutions, leading to AWO. Thanks to computational power, the integration process has continued to grow. The diagram presents the original S&OP model, and the current version, which integrates more and more models. This evolution has led to modeling based on artificial hypothalamus, supported by the integration of mathematical programming and artificial intelligence. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. Thematic Plan. The course has been divided into 12 virtual sessions, which are explained below. Session 0A, Economic Value Added by Mathematics, State-of-the-Art of Optimization, Fundamentals of Optimization. Introductory sessions that serve to level students' knowledge on the topic of optimization. It is taught under the virtual modality, recorded classes by AI. Session 0B, Artificial Brains and Hypothalamuses, Parallel and Distributed Analytics. Introductory session that serves to improve students' knowledge of analytical methodologies. The vision of the future of the RCADT is presented, which is summarized in the work on the development of the artificial brain as an integration of mathematical programming and artificial intelligence. The course introduces the integration of predictive analytics and prescriptive analytics to produce optimal maintenance plans. It is based on realistic use cases of real industrial systems and considers the impact of Industry 4.0. Session 1. Predictive Analytics. Different methodologies used by predictive analytics are presented. Specifically, the following are studied: artificial neural networks, vector support machines, probabilistic models of state estimation. The objective is for the student to have a clear idea of the methodologies used in the applications and use cases presented in the applied sessions. Session 2: Prescriptive Analytics. Different methodologies used by prescriptive analytics are presented. Specifically, the following are studied: fundamentals of optimization, duality theory, stochastic optimization, risk management. The objective is for the student to have a clear idea of the methodologies used in the applications and use cases presented in the applied sessions. Session 3: Asset Management in Industry 4.0. Three aspects are considered: general theory, types of maintenance, and measurement systems. Modern maintenance is based on determining maintenance activities based on the holistic knowledge of the following maintenance conditions: system, production unit, equipment, and part of equipment. Condition-based maintenance, CBM, represents the evolution from reactive engineering to proactive engineering, having passed over time for the following stages: repair or replace when broken. Reliability-centered maintenance, a systematic approach to ensuring that assets continue to do what is required in today's operational context. Enhanced diagnostics, process that explains why a component has failed, and condition-based maintenance, predicts the future state of a component, so that maintenance is performed based on that state. Sessions 4 and 5, PHM, Prognostic and Health Management. PHM systems are one of the main protagonists of the Industry 4.0 revolution. Effectively detecting if an industrial component has deviated from its normal operating condition, or predicting when a failure will occur, are the main challenges that PHM addresses by decreasing the probability of failure events and improving the level of safety of industrial machines. PHM is directly linked to CBM and can be said to be the current practical methodology for implementing CBM considering Industry 4.0. In addition, PHM drastically reduces costs, visible and invisible. The course introduces PHM theory and implementation through detailed use cases, discussing an analytical system for PHM for various types of components. The objective is to present the use of prescriptive analytical methodologies to optimize decisions related to components, assets and the network of assets, taking into account that industrial plants and systems result from the integration of multiple assets. This implies the need to know the behavior of the components and how they are integrated into the system, and how such integration gives rise to networks of components and equipment, and that failures, and therefore maintenance needs, occur at any level of the network. Optimization methodologies used are: asset network maintenance, stochastic optimization, financial risk management, industrial production systems. Sessions 8 and 9, drone maintenance activities. The math methodologies used are: image processing using neural networks, route planning using mathematical programming. Use cases: applications in space-dispersed production networks. In recent years, UAS, unmanned aerial systems, have been seen as a new smart tool in many sectors, including public management, emergency rescue, electrical asset maintenance, agriculture, transportation, and space inspection, among others. These smart tools have expanded people's capabilities, kept them out of harm's way, and improved work efficiency. UAS systems, such as fleets, swarms, of drones, are increasingly being used to automate the planning, construction, and maintenance of industrial facilities around the world. The effectiveness of UAS and digital technologies are transforming energy sector operations to be faster, safer, and more cost-effective. The course implies PHM applications. The methodological aspects that must be considered in the handling of drones are: image processing,
planificación y programación de rutas, y pilotos automáticos,
route planning and scheduling, and autopilots. Session 10, complementary applications. Logistics activities in the context of maintenance decisions are part of the problem that must be solved by the professionals involved in the management of the maintenance of industrial assets. This session addresses four main logistical issues: inventory policy optimization, Determine minimum safety levels for spare parts inventories. Work team scheduling, optimal coordination of teams to manage maintenance problems. Major maintenance planning, optimal planning of maintenance activities that extend over time and share resources. Programming of activities in workshops, programming of activities that will be carried out in the maintenance workshops. The course director is the founder and scientific director of R-CADT. Engineer Velasquez Bermudez's experience in applied operations research dates back to 1972, which means that he has accumulated more than 50 years solving real-world problems, doing engineering consulting using mathematical models. This is the technology transfer that those attending the course will receive. The table presents the plan of topics planned for the course Industrial Asset Network Maintenance and PHM, Prognostics and Health Management. R-CADT is the most applied academic center in the integration of the teaching of mathematical programming and artificial intelligence. For more information you can consult the URL. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." Thank you for your attention.